In this video, we'll work problems that apply the laws of exponents. Not for Bruce, though. Bruce is done for the day. Nap time for Bruce. The first law of exponents that we studied said that when you multiply with like bases, you add the exponents. X to the m times x to the n is x to the m plus n. So if we are to simplify this expression, y to the third times y to the fifth, we're multiplying like bases, we should add the exponents. 3 plus 5 is 8. Done. This one's got an extra step, because this is a plain old -4, and this is a plain old 5, and I'm multiplying. Multiply -4 times 5, and I get -20. Now look at the x's, where we're multiplying with like bases, which means we must add those exponents. 2 plus 8, that's 10. You multiply the coefficients, but you add the exponents. In these problems, we'll use a new law of exponents. When we take a power to a power, we multiply the exponents. X to the m raised to the n is x to the m times n. Look at number 1. We're taking a power to a power. When that happens, you multiply the exponents. 7 times 2 is 14. On this one, be careful with this 5. This is a plain old 5, and it's being squared. 5 squared is 25. Then when we look at the x, notice we're taking a power to a power. We multiply those exponents. 4 times 2, that's 8. Here's the way I want this to look. Problem and answer, problem and answer. Here's the third law of exponents. If you take like bases and divide, you subtract the exponents. X to the m divided by x to the n is x to the m minus n. For this first problem, m to the 8th divided by m to the 3rd is m to the 8 minus 3. That's m to the 5th. Perfect. Before I start number 2, I'm going to notice that these two variables don't have exponents on them, which means I can put an exponent of 1 for each one. Let's try it. For the x's, I'm dividing. When I divide, I subtract the exponents. So for x's, it's 7 minus 1. For the m's, 6 minus 1. 7 minus 1 is 6. 6 minus 1 is 5. So this expression simplified is x to the 6th, m to the 5th. All right, you go try a couple of problems and then meet me back here.